like to ask Frédéric Chaki for his lecture. He comes to us from the University of Lyon, of INSA Lyon, and he will talk to us about the challenges of a hybrid world. Thank you very much.
Okay, thank you very much. Thank you for the invitation. First, I will apologize because I didn't do my PhD with France. Really sorry for that, France. My presentation is about the challenges and opportunities of the hybrid world. And basically, it's about trying to look into the future from what we are now and what we could be in the future. A quick introduction of myself. I'm associate professor at INSA Lyon and University Lyon 1, research fellow at the University of Melbourne, and I'm working now since quite a long time on sustainable urban water management, sewer asset management, nature-based solution asset management since more recently, and innovative monitoring technology. And here is my email if you have any question. Before starting the presentation, I would like to know if there are architects in the room, because the presentation will be different. Okay, so we choose the yes. Okay, so this is the presentation. So the idea is to discuss about the hybrid world and to discuss about the different meaning of the hybrid world, and so we will of course speak about gray, green and blue, and then we will discuss about the service delivered, the idea of temporal spatial scale, the status of rainwater, and we will move forward to stakeholders and hybrid intelligence, and then open to urban evolution. So we need a starting point. So this will be the starting point, because I like very much this picture. And this picture is showing a drainage network in London. Really nice picture. So let's start with the drainage network. And let's start at the end of the 19th century, so 100 years ago. Mainly because of sanitation, centralism, the fact that we all want to bring something in one place, and we are very proud of that in France. If you go on highway, train, whatever, it's always going to Paris. If you want to go from, let's say, Lyon to Bordeaux, you have to go to Paris. That's centralism. And there was also the scientism saying that science can solve everything. We can build everything and solve everything. And at this time, there was also, we were very rich. So if we had to build drainage network today, it would be impossible. We don't have the money to do that. So we came up with the network. And the network, we came up for the network for the drinking water, for the drainage network, and for sewer. I would like to show you a picture. This picture comes from a book written in 1900, so 100 years ago. Some writer write about the world in 2000, 100 years later. And that's the picture from the book. So in 1900, Albert Robida, a French writer, not very known, write this book. And in this book, there is this picture, this drawing of what could be the city in 2000. And in the city of 2000, you can see that there is the drinking water pipes, there is the sewer pipes. Drinking water pipes are quite big, anyway. And then you have the television, but television is not what we know now as television. It was more video conferencing or something like that. And you have also the music, the theater, which is internet for us. And you have the mechanical energy, and you have the light. And the last one, the one that you cannot see here, it's smaller and written in French, that's the food. So basically, imagine that in the year 2000, we will have a food network. What does it mean? It means that you have the food company, and the food company will deliver food directly to your home. So you will have the soup, could be easy. Then you have the fish, the beefsteak, everything will come to your home, even the alcohol or the water or whatever. And of course, we joke about that. Not only because we are French and the food is very important. We joke about that because it doesn't seem possible. But that was the idea of the network, the idea that network can solve everything. So that was really the idea in the last century. And so we build what we call impervious city. And the idea is to collect the water and put it outside of the city. So we are doing impervious city with huge drainage network. You can even have a car in some drainage network in France and in other countries. And you have the funnel effect. You're also concentrating all the water outside of the city or on a specific point, which we know now is not good. So now we are trying to move to what we call the water-sensitive city or the sponge city, or there are lots of different concepts. And this idea is to have a pervious city. And in the water-sensitive city, the idea is to make the city transparent to the water cycle. So basically, all the water cycle should be the same before and after the city, which is quite difficult, but that's the main idea. So we are moving to this water city. To do that, you all know we are pushing for what we call nature-based solutions, stormwater control measure, and they have many names. And usually the idea is to have some detention and filtration, and to manage water as close as possible to where it rains. And so that's where we are now. We are at the beginning of this nature-based solution to manage stormwater. And this is also the beginning of the hybrid world. Then hybrid world, the first hybridity is about the fact that this nature-based solution is made both of natural and engineered part. And you expect performances or services both from the technical part and both from the natural part. And you also expect services from the combination of both parts. So you are in this hybrid expectation from the system. It's also hybrid because you have to manage it in a hybrid way. You have a swale on the right, and you have an infiltration basin on a swale on your left, infiltration basin on your right. You have technical management. You will dig, you will change part of a layer. So it's all built, and as soon as you finish the work, it should be good, working as you expect. And then you have the more natural part, where you can also manage, but it's more difficult to manage, and you cannot do what you want, and you cannot expect the result as soon as you finish to manage. You may wait for the nature to grow. It's not as easy as it is. So hybrid is at the level of the system, and both based on the expectation and the combination, the component inside the system. But hybrid is also at the scale of the city. We will never get rid of the network, the pipe network, because it will be too expensive to get rid of them, and they are also working well in different situations. So the city we are building, it's hybrid. It's both with pipes and both with nature-based solution. But the whole system needs to deliver services. When you're looking, for example, for flooding, you need to be sure that you have the same flooding protection for the whole city, combining pipes and nature-based solution. But they are managed separately. So that's not working well for now. So it's also hybrid at a larger scale. And it's also hybrid from the expectation you have from the system. At the city scale, when you had only pipes, the idea was to collect and to convey outside of the city. And that was what we need from the pipe, and it was working. And now it's much more complicated. So you expect much more services from the system, from this hybrid system. Of course, you have traditional expectation about flooding, human health, and so on. But you also have new expectation because some of the nature-based solution will be on surface and will be in contact with the population. So you need to be sure that it's used and it's working with the inhabitants. And you are also using part of the surface of the city. Could be a road, could be a sidewalk. So you expect also that this nature-based solution will also be a sidewalk or a park or a soccer field or different things. So the expectations are much more important. And these expectations are also on a very different temporal and spatial scale. If we consider that we build nature-based solutions to mitigate climate change, that's a huge scale because we do that at the scale of the planet. And that's also on the long term. Not so long now, but supposed to be on the long term. If you consider the flooding, it will be very local and it will be now. So you have to deal with very different scale for this expectation. And so if you design the system, if you assess the performance of the system, you have many different services and you can choose on what are the frontiers of the system. That's quite difficult. If we go back to the rain itself, the rain is also hybrid. The stature of rainwater is really hybrid. For a very long time, we have considered the rainwater as a threat because it's flooding. It could be dangerous, it could be damaging. The video come from Paris in 2011. And so you can consider the rainwater as a flooding problem that you have to manage. But the rain is also a huge resources for city for drinking water. Some cities do not have drinking water, so you can use the rain. You can build very nice landscape with the rainwater, and you can help to preserve and develop the biodiversity. And so it's also hybrid on this. If we deal with this, the fact that the water is hybrid, there are solutions to deal with that. I have, for example, you all know this is a rainwater tank. So basically the water will come from the roof, will be collected in the rainwater, and then the rainwater will be used for washing machine, toilets, or watering a garden. And then you have an overflow. When it's raining too much, you overflow. So that's the basic system, and with the rainwater tank, you're doing resources harvesting. But you can do more. First, you can install a valve and control the discharge, not wait for the overflow. If you do that, you can also connect with the forecast. And you can use the forecast to empty the tank one day before the big rain. So if you empty the tank one day before the huge rain, you do pre-storm release and you add the flooding risk. You are managing flooding also. You are managing both the resources, the water as a resource and the water as a threat. So that's quite good. We can do that. And we have shown that we can go further. You have now 7-day forecast. That's something that it's developing more and more. And the 7-day forecasts are not so accurate, but they are becoming more accurate. So if you have a 7-day forecast, what you can do is start to release 7 days ahead of the big storm. So what's the difference? The main difference is that you release much slower. So the flow will be slower, will be reduced, and you won't send a big flow to the stream. So you will also work for stream preservation. And so with this 7-day forecast, you can combine the water as a resources to avoid the flooding, and you can also work for the biodiversity because you will protect the stream and you will start to have this idea that the city is disappearing on the water cycle. And so this is possible. And why is it hybrid? It's hybrid because now we are combining the traditional system. Rainwater tank is very old. And the swale, a trench, they are all very old systems. But what we are doing now is that we connect communication and control, and we are doing real-time control and real-time monitoring. And so combining this past and the future, this hybrid will help us to make the most of this system and make them adaptable to today's life. So that's another way of seeing how the world is becoming hybrid. And then you have the stakeholders. When you are designing a nature-based solution or urban drainage system, you need to involve many different stakeholders. You have the urban planner, the land developer, the architect, landscape architect, and so on. And then when you will do the design and the operation, you involve many stakeholders. So it's hybrid in the sense that you really need to have different stakeholders to work with. And there is a very important stakeholder that is not here. And an important stakeholder that was not really necessary before with pipes. This is the inhabitant, the citizen. And we are discussing more and more about what we call the hydro-citizen. The hydro-citizen, there is no official definition, but basically it's a citizen, inhabitant that is aware of the water as resources and as a social link, and who wants to be active, for water management. That's maybe the inhabitant living close to a wetland that will help you to manage it and just be aware of what it's it for, and start to be part of the solution. So lots of stakeholders. And we can also discuss, we were discussing this morning with Franz about the fact that you have also the public and private land, and that's very different. That's also another way of seeing hybrid system. I have a quick example about that. So this is in Lyon. This is a small swale along the road in Lyon, and so the swale has to be managed. So we were discussing with the manager of the swale and how this swale is managed, and that's quite interesting. The grass is managed by the green space department. They have to mow the grass, and so because it's a green space, the green space department will be in charge of that, and that's part of the city. And then you have the tree. The tree is managed by the road department. In the road department, they have a specific department dedicated to tree along the street. So they are in charge of that. So they are managing the tree. But you have also the cleaning department, because there will be cleaning to do. So they will be managing also not only the street, but they will clean the swale. And you have also the road department, because the swale is close to the road. So when you will do works or intervene in the road, you have to be careful with the swale. And maybe you'll also have the drainage department, because the swale was supposed to work to be about urban drainage, so they are part of the team. And so that's really an illustration of the fact that it's hybrid for the stakeholders. And that's very complicated to deal with, because there is no perfect solution. So it's a lot about task attribution and knowledge sharing. If I go there and clean the swale and I see that something is going bad, I have to know who I need to tell about that. It's also about common language, because we are all in our field and we need to work together. And at the end, it's a lot about cost sharing. And I've seen projects, very nice projects, that have been abandoned because nobody wanted to maintain the project, because it was a new cost and nobody wanted to be part of that. So hybrid. And then you have the human versus or with artificial intelligence. In asset management, we often use this definition that infrastructure asset management is the art of balancing performance, cost, and risk in the long term. So you have all the keywords: the performance of the system, the cost, renewal cost, operation and maintenance cost, and impact cost, and then you have the risk, flooding risk or whatever. So the asset management is all about finding the best solution for your asset, for your system on the long term, given all of that. And if you start to ask the utility manager on how they are doing that, there was a very good PhD a few years ago by Wouter van Riel here at TU Delft. And when you ask them, you learn that a big part of the decision is subjective. It's based on your experience as utility manager. You've seen things and you have your experience. A part is also based on gut feeling, what you think is right. But of course, you also use models and data. So you have to combine this subjective decision with computer-aided decision. And it's really hybrid in the way you have to manage it. So in some way, you may need artificial intelligence to learn not only the science of asset management, but this art of balancing between performance, cost, and risk. And if I have time, I guess I have some time, yeah. I want to go on this one and discuss this idea of asset management and long term. Let's consider that you are a utility manager and you have a very ugly and new retention basin in your district. And the question you ask is, what do I want to do in 20 to 50 years? One idea could be, I want to do nothing. I want to leave it as it is because then I will decrease the maintenance cost and maybe it will work. So the do nothing solution is a solution. It's often the solution that is taken for nature-based solution because we don't know really how we can do things and we are not monitoring, so we wait for the failure. So basically the idea is do nothing until we are obliged to do something. You can decide that in 50 years you have to double the volume because you know that climate change is arriving and there will be more rain and you need more volume to manage the rainwater. That's another idea. You keep the same system, you just extend it. You can decide that you need the space, so we will change it. And in 50 years, we need to have something underground. So we have the space on surface, and so we change the system and we hide it. Could be another solution. Some new solution is, the idea is to integrate. You have this retention basin, and you change it to wetland. And then you have the nature, the vegetation, you still have the retention, and that's totally different. It's integrated. Or you have the retention basin, and you do a playground in the retention basin. And you manage that it won't be flooded every 5 years, something like that, so you can make things, and it's integrated. You're not losing the space. It's not raining so often, so it's a shame to have something dedicated to rain because it's not raining so often. So you can use it to something else. Or you can adapt it and you change it. And instead of having a big system, you start to make train techniques or cascade techniques. And you may have a small retention basin and then a swale or an infiltration basin, and you connect that. And the idea will be that the space used by the system will depend on the rain. So small rain, only part of the system is used. Big rain, all the system is used. And the system is used for something else. It could be a park, it could be again a soccer field or whatever. So you change this big system into a train system, a series of different systems. And if climate change is arriving, maybe you can add one at the end or at the beginning, or you can change only part of that. And adaptability is something which is more and more important for us. And adaptability is not working well with pipes. You cannot increase the diameter of a pipe. So the system we choose are very important from the start. And then hybrid also in the way we consider the urban evolution. For a very long time, we have considered that we were doing modeling and simulation on the long term for drainage pipe. We were doing modeling and evolution for transportation. But now we are combining all of that. So we are starting to be able to have urban modeling, and in this urban modeling, you can try to predict the evolution of the population in 10, 20, 30 years. You can combine that with the evolution of the transportation system. Will it be more cars, less cars? What will be the system? You can combine that with economy. What kind of people will install? What kind of economy you will have? Job, land use, and the building, and energy, and the waste management. You can combine all of that in the urban modeling. And we all know that we are definitively not sure of having the correct outcome. So what we are trying to predict in 30 years may be totally different. But the point is not really about the accuracy of the prediction. The point is much more about the fact that to build this kind of model, you need all the departments to work together, and you need all the departments to share what is their vision of the future. So if I'm planning the drainage network with pipes and nature-based solution, I need to know how will be the population, how will be the transport, how will be the street, and so on. So I need to discuss with all of these people. And even if the model is not good at the end, at least I have made the connection and I can better imagine the future. So that's all about our hybrid world. And if I summarize in this slide, it's hybrid because of the rainwater statute, because of the urban complexity, the stakeholders, the gray, green, blue, the spatial temporal scale, the service delivered, the human versus artificial. There are lots of ways of speaking of hybrid system. It's not only blue, green, gray. And these are two nice visions of the future by two different architects. And for me, the most important behind that is that we need to start to think out of the box. Because it's not only, Franz will discuss much more about that, but it's not only about engineering solution. So I have a good example of thinking out of the box. And that's for you to work now. You have this very nice equality, but it's not working well. So the idea is to add one character to make it work well as an equality. So who has some clue? Who wants to try? Okay, so the first guess is I just add this and say it's working now. No, it's not working because it's not an equality. So that's not the good solution. You're not thinking out of the box. No, it's not good. It's not good because I want an equality. It's true, but it's not the solution. So you're not thinking out of the box. So you really need to think out of the box. Thinking out of the box is yep. Yes. Thinking out of the box is not considering that they are all Roman numbers. It's considering that you need this equality and you need to go outside of this. And you have to add a letter. It's not a Roman number. And thinking out of the box is, it doesn't mean that you need lots of knowledge. It's more that you need to go back and start to look at a different picture, a bigger picture. Okay, that's almost finished. I wanted to finish. I gave this morning to Franz a balancing gift because the title was Balancing Act. So I gave some Lego to Franz. And I was not sure, so I gave 8+8 Lego. And only 56 pieces, you never know. And Franz had to build it for, yeah, okay. He had to build it for now. He didn't have time to build it. So I will show you what I gave to him. That's something like that. Have you seen this? Yeah, maybe you know that. They often call it tensegrity. So it's very strange. And when Franz will finish to build it, you will see that. It's kind of very strange structure that is working well, but it's totally unintuitive. If you look at that, it's unintuitive. And again, it's thinking out of the box. Because if I show you this, you will say it's not working, so you have to see it. So I don't know when, but when you will go and see France next time, you will see it. Yeah. Okay, and then I need to, yeah. I have finished my presentation. This is more advertising. With a colleague, we are leading a special issue in the nature-based solution Elsevier journal, which is a recent one. So if you want to submit article about hybrid gray-green infrastructure, this could be the place. Thank you very much.